Thank you, welcome. Let me take you through this question. I have a question here which says that scoop a liter of, before even you scoop, we want first to identify whether this is an organic analysis, qualitative analysis, or it is inorganic. So what you do, you just read it through the question, A or B or B1, read through these questions and then see the reagents that are used there. And then we will be able to conclude whether it is organic. Scoop, that one will not tell us. Add the remaining solid, that one will not tell us whether it is organic or not. So we come to 3. To the first portion, add 3 drops of the universal indicator. Now, universal indicator is used to test for the strength of the acid. That one, so we move ahead and continue. And then look at this one. To the second portion, add acidified potassium permanganate, warm chain 3. Yes, so that one now is almost confirming to us that this one is organic chemistry. And then lastly, we can check here acidified potassium dichromate, warm chain 3. Oh, now that one we know. Here we are going to infer, giving the double bond, the functional groups of the. Now, scoop a liter solid Q, a metallic, heat it over a Bunsen burner. Then we want to give both the observation, solid Z melt then and burn with a sooty flame. So solid Z melt and burns with a sooty flame. What was the type of sooty? Yellow. I think I have skipped it. With a sooty yellow flame. Then if that is the case, then it is simply telling you that whatever is inside that solid is unsaturated salt. You can either say unsaturated organic compound. It is unsaturated organic compound, or you can say unsaturated, we have the double bond. Then make sure the 4 covalent bonds are there, or the triple bond. Present. Add the remaining solid to about 10 centimeters cube of distilled water in a test tube and shake. So here the solid dissolve forming a colorless liquid. So the solid dissolve, forming a colorless liquid. So that tells you that that solid is polar in water, because water itself is polar. Therefore, we have polar organic compound present. Polar organic compound present. Next one. Now this solution we have made here, we divided that solution into 3 portions. To the first portion, add equal 3 drops of universal indicator using the pH chart. State your observation and inference. Now here, we talked about the pH. If the pH, for example, if you find it is red, then the pH is 1, and then you will say strongly acidic. If the pH is and you find it is yellow, that means it's is pH 6. It means it is weakly acidic. So here it depends the color of the pH scale you are using. The pH chart is the one which is going to give you the color. To the second portion, add 3 drops of acidified potassium permanganate, warm gently. Then you say purple acidified potassium permanganate is decolorized. Is decolorized, meaning that the purple color changes from purple, or the color change from purple to colorless. The color change from purple to colorless, that means decolorization. Therefore, it confirms that the double bond, and the triple bond is there. The triple bond is there. So you can even say confirmed. The next, to the fourth portion, add 3 drops of potassium dichromate and warm gently. Then in the orange acidified potassium dichromate remains orange upon warming. So after warming, the orange color still remains. Then what it means? It means this one is absent. If this one is absent, which is an alcohol, and the alcohol is saturated, then it means that the unsaturated are there. So the negative of this answer, you can say that this one and this one present. Yeah, but you can write this, the alcohol is absent, because we expect when you warm acidified potassium permanganate, if there is an alcohol inside it, it will turn green. But if it doesn't turn green or change to green, then it means that the alcohol is absent. So that one is fine. To the third portion, add half spatula of sodium hydrogen carbonate, and then there is effervescence. Effervescence occurs. Then it means that there was an acid inside there. Therefore, we can say the carbonic, or no, not carbonic, but organic acids are present. You can also use the hydroxonium ion. It is acceptable. Present. So that is it. You know, these things repeat themselves. So let us compare another. There's another paper there. Let's look this one. Let us look at this. You are provided with solid pen. Carry out the test below and record your observation and inferences in the space provided. Using a clean metallic spatula, heat a third of the solid P in a Bunsen burner flame. Solid P melts and burns with a sooty or a smoky flame. So you see, it is burning with a smoky. That's what we have done. So these things, they are just repeating themselves. Divide both the dissolve the remaining portion of those tube, adding this or that. Then the solid dissolve to form a color solution. We have said that. To the first portion, add 3 acidified potassium manganate 7 warm. The purple acidified potassium manganate 7 is decolorized. So we have answered that. To the second portion, add 2 to 3 drops of bromine water. So bromine water is decolorized. So when bromine water is decolorized, we have made it means that the double bond, the triple bond, the unsaturated functional groups are present. For bromine. And then to the third portion, add a spatula of sodium hydrogen carbonate, then effervescence occurs with the production of a colorless gas. That one we have answered. Universal indicator, the pH solution, then the pH is 4. So when the pH is 4, 4 is a weak acid. Up to 4 is a weak acid. So we can say weakly acidic. So you can see this organic chemistry, it just repeats itself. So once you have mastered the functional groups of the saturated and unsaturated organic compounds, then it becomes very easy. Thank you. You are provided with liquidity. Carry out the test below and write your observations and inferences in the space provided. Pour a small portion of liquid tea into a clean glass watch and ignite it using an unluminous flame of a Bunsen burner. Observation. So we are heating a small portion of a liquid on the glass watch. So the observation we want to give is that the liquid burns with a blue non-sooty flame. The liquid burns with a blue non-sooty flame. Blue non-sooty. Another person can say pale blue or blue. It's acceptable. So when a liquid is burning like that, and we have already determined that this part is organic chem, then what is here is the unsaturated organic compound. So, or you will use this one to represent the alkane. Alkanes are saturated, or the alcohols. Alcohols are saturated organic compounds. Measure 1 centimeters of liquid tea into a test tube. Add 2 centimeters cube of distilled water and shake. Retain the mixture for the test from and 3 below. So we are adding liquidity into water. Remember, we are adding a liquid. Therefore, a liquid, when you add it into water, it does not dissolve. But we want to check whether the liquid is miscible and it is going to form a layer or not. So for this one, liquid T is miscible, meaning it mixes in water, forming one layer, a uniform layer. So you can also say that no two layers, no two layers. For if there is no two layers, then it means it is miscible. This one is just an option, so the correct one is the liquid T is miscible or mixes to form a uniform layer. Therefore, then it means that the liquid is polar. Polar organic compound. All right. Next question, number Roman 3. The mixture in Roman 2 above, to the mixture in Roman 3 above, add 2 drops of a universal indicator, and determine its pH. So the pH, using the pH chart, the pH was identified to be 6, the pH of 6, and 6 is a weak acid, so you say weakly acidic. 6 is yellow, so the color is yellow, therefore we give it a weak acid. To about 1 centimeters of liquidity, put a half spatula of powdered sodium carbonate, and then there is no effervescence. Remember, when we are adding sodium carbonate, effervescence. When we are adding sodium carbonate, we expect effervescence because sodium carbonate is a base. If it is an acid, it will react and it will produce carbon dioxide, and then effervescence will occur. So if effervescence does not occur, then we say no effervescence. So if there is no effervescence, it means there is no acid in that solution. Then we say it is the alkanoic acids present. Present or absent? Absent. If it was present, there would be effervescence, so it is absent. To about 1 centimeters of liquidity, add about 1 centimeter of orange acidified potassium dichromate. Warm the mixture and allow the mixture to cool for about 4 minutes. Then what happens? The observation is that the orange acidified potassium dichromate turns, but we have reviewed this to use the term turn. This year they were rejecting the term turn, therefore say changes to green on warming. On warming, the orange acidified potassium dichromate changed to green, therefore it confirms that the liquid we have, the liquid T, is an alcohol present. Thank you.